All right, today we're talking about something huge. Two revolutionary technologies, AI and synthetic biology, are coming together. And believe me, this partnership is set to reshape our world in ways we're only just starting to wrap our heads around.
So let's start with a big question, a really big one. What if we could program life the same way we program computers? I mean, really think about that. It sounds like something straight out of science fiction, right? But it's quickly becoming scientific fact. And it's all thanks to this incredible team up between artificial intelligence and biology.
Okay, so to really get how this collaboration is changing everything, we first need to break down the two key players in this story. First up, we have synthetic biology. Now, the easiest way to think about this is biology meeting engineering. We're talking about tinkering with the very building blocks of life, like DNA, to create completely new biological systems that can do new things. The whole goal? To make the incredibly complex world of biology, well, engineerable, something we can actually design and program. And on the other side of the equation, you've got artificial intelligence, or AI. You know the deal here. It's all about simulating human intelligence in machines. It's this amazing tool that can sift through enormous amounts of data, find patterns that a human could easily miss, and then make decisions, often with very little help from us. So here's where it gets really interesting. When you put AI and synthetic biology in the same room, it's not just a simple 1 plus 1 equals 2 situation. Oh no, it's a multiplier. AI acts like a powerful catalyst, just pouring fuel on the fire and dramatically speeding up the entire process of biological discovery and engineering. And this acceleration, it's literally rewriting the rulebook on what's possible. So how exactly is it doing that? Well, let's take a look at the powerful cycle of innovation that's driving all of this forward. At the heart of all this is a 4-step loop: design, build, test, and learn. Now, in the past, this process it was painfully slow. I mean, we're talking years of work. But now, AI comes in and just supercharges every single step. It helps predict the best designs. It assists in automating the build phase. And then it analyzes mountains of test data to learn what worked and what didn't. This creates this incredible feedback loop, a cycle of discovery that just spins faster and faster and faster. And this isn't just theory. This cycle is already delivering some jaw-dropping breakthroughs. In medicine, we're seeing AI-driven drug discovery for things like cancer. We're developing incredible new materials, like stuff that can actually heal itself. In agriculture, we're creating crops that can withstand the crazy weather that comes with climate change. We're even engineering tiny organisms to help us clean up pollution. I mean, the potential benefits here are just staggering. So when you add all this up, you realize it's so much more than just a few cool lab experiments. What we're witnessing is basically the industrialization of the life sciences, but at the genetic level. It's nothing short of a new industrial revolution, but for biology itself. But, and there's always a but, isn't there? With all of this incredible promise comes some very significant peril. Every truly powerful technology has a dark side, a potential downside, and it's absolutely crucial that we look at the other side of this revolution. I think this quote just nails it perfectly. It's like we're holding this powerful double-edged sword. On one side, it promises to solve some of humanity's biggest challenges, but on the other, it carries some very, very real risks if we don't handle it with extreme care. And look, these aren't some far-off what-if scenarios. We are facing a whole new class of risks, right now. There's the huge concern about dual use. What if this tech gets misused to create biological weapons? Then there's the danger of AI bias. If the AI is trained on biased data, it can lead to medicines or treatments that don't work for everyone. And what happens if we release synthetic organisms into the wild? We can't always predict how they'll behave. And that's not even getting into the massive philosophical questions that come with the ability to create artificial life. So, all of this brings us to probably the most important question of all. How in the world do we govern this new frontier? How do we find a path forward that lets us reap all the benefits while keeping the dangers in check? You know, one of the biggest challenges is just completely rethinking how we do oversight. The old school way, the human-in-the-loop model, where a person has to sign off on every single step, it's just too slow for the speed of AI. So we have to shift to a human-on-the-loop model. This is where human experts are watching over the automated systems, ready to step in if something goes wrong, but not micromanaging every little thing. This is absolutely essential if we're going to manage these new, super-fast automated labs, the ones we call biofoundries. And building that kind of oversight means we all have to commit to responsible innovation. What does that look like? Well, it means creating regulations that can actually adapt and keep up with how fast this technology is changing. It means making sure everyone, scientists, policymakers, industry folks, and yes, the public, is part of the conversation. And most importantly, core principles like safety, transparency, and accountability can't be an afterthought. They have to be baked in from the very beginning.
So we end right back at the central challenge, the big balancing act. We have this incredible engine for discovery in our hands, but it's pulling us into completely uncharted territory. The question really is for all of us. How do we steer this thing? How do we balance this incredible accelerating pace of discovery with the need for safety, security, and fairness for everyone? It's a delicate balance for sure, and it's one we absolutely have to get right.